Hi everyone, in today's lesson from Unit 3.2, Part 2, we're going to take a look at how the distance formula is derived from using the Pythagorean theorem on the coordinate plane. So as a review, in number 1, we want to find the length of the segment, or the distance between points A and B. So recall that in our previous lesson, we would turn this into a right triangle by sketching in the horizontal and vertical segments and counting to find their lengths. So the vertical segment has a length of 1, the horizontal segment has a length of 3, and we'll just call this distance d. So you could say that d squared would be equal to 1 squared plus 3 squared, or d squared is equal to 1 plus 9. D squared would be equal to 10. Then we have to take the square root of both sides. So that's going to tell us that our distance is equal to the square root of 10. So AB has a length equal to the square root of 10. And we'll just keep it in exact form. Okay, for the length of line segment CD, if we connect those two. And again, let's turn this into a right triangle by dropping in the vertical segment and horizontal segment. The vertical segment has a length of 2. Horizontal segment has a length of 3, and again we'll call that distance d between them. So this time around, d squared is equal to 2 squared plus 3 squared, or d squared is equal to 4 plus 9. D squared is equal to 13. So take and find the square root of both sides. We get d equals the square root of 13. So that means the line segment CD has a length equal to the square root of 13. Okay, next we are asked to find the length of the segment connecting points E and B. Let's see. We're going to draw a really big triangle in here. So I'm going to go all the way from E to B, and we are going to turn that into a right triangle by drawing in the vertical line segment and horizontal line segment. Okay. So let's just highlight that in black here, show up a little bit better. So that distance, d squared, would be equal to the length of this vertical segment, which has a length of 5, and the horizontal segment, which has a length of 9. So d squared would be equal to 5 squared plus 9 squared, or d squared is equal to 25 plus 81. So d squared would be equal to 106. So d is equal to the square root of 106. Okay, and d equals the square root of 106 is how we're going to leave our answer. So EB would have a length equal to the square root of 106. Now you can imagine as our segments get longer and longer, our triangles will get bigger and bigger, and it will become a little bit cumbersome to try to do the Pythagorean theorem in every case. So if you notice, the length of one side of the triangle can be found by looking at the change in the x values, and the length of another side can be found by looking at the change in the y values. For example, if we call this point E, if we name it x1, y1, and we name this point x2, y2, then we can say that the length of this side of the triangle could be found by taking the x2 value and subtracting x1 from it. Okay, so that would give you, and the distance is positive, so you'd have to take the absolute value of that difference. For this vertical line segment, we can express the length of that as y2 minus y1. Okay, so the distance formula is based on the Pythagorean theorem. You can say that d squared, that's our hypotenuse squared, is equal to the quantity of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Now keep in mind that The 2's and the 1's just tell us that they're from different points. They're not exponents. It's something called a subscript. Okay, so to solve for the distance d, we need to take the square root of both sides. So when we do that, sorry about that. When we do that, the square root of d squared equals the square root of all of this on the right-hand side. So it'd be the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So finally, this will give us our distance formula. D equals the square root of the change in the x values, that value squared, plus the change in the y values. Okay, so let's take a look and see how this can make our work finding the distance between 2 points a little bit easier. Okay, in 4 and 5 it says use the distance formula to find the distance between each pair of points. Leave your answer in simplest radical form. So first let's write the distance formula at the top here. D equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So it doesn't matter which point you label as x1, y1. So I'm just going to choose this as our first point, x1, y1, and then this is our second point, so it'll be x2, y2. Okay, so we're going to write d equals the square root, and then we just plug in our points. So negative 2 goes in first, negative 2 minus our x1, which is 1, close those parentheses, square it, plus y2 is 9, minus y1, which is 5. Okay, the trickiest part to the distance formula is just keeping track and watching all of your signs. Negative 2 minus 1 is negative 3. We're going to square that quantity. 9 minus 5 gives us 4. We'll square that. So just keep going and simplifying. Negative 3 squared is 9. 4 squared is 16. This one's going to work out really nicely because 9 plus 16 is 25. And the square root of 25 is 5. So the distance between these 2 points is equal to 5 units, and notice there's no graphing needed. Okay, in the second example here, distance equals the square root. Again, it might help to label your points first, so x1, comma y1, and x2, comma y2. So plugging your points in, do x2 minus x1, so 12 minus 6, quantity squared, plus, now do y2 minus y1, so 2 minus a negative 2, quantity squared. So again, watch those signs. 12 minus 6 is 6, and we're going to square that. 2 minus a negative 2 turns into 2 plus 2, which is 4 squared. So d equals square root of 36 plus 16. So d equals the square root of 52. And we're going to simplify that next. So factor the 52 into 4 times 13. And then 4 is our perfect square. Take the square root of 4 and we get 2 square root of 13. Final answer. In number 6, it says the distance formula can be used to classify triangles and quadrilaterals. Use the distance formula to determine if the triangle with vertices at points A, B, and C, as listed, is isosceles, scalene, or equilateral. So we're going to use the distance formula to prove whether or not sides of this triangle are congruent to each other. So distance equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Now, sometimes it's helpful to draw a sketch. We're not going to use graph paper in this case, but just going to label the points. Let's go with point A here at negative 3, 4. Point B here at 3, 1. and point C here at 0, -2. Now what we want to do is find the lengths of all three sides. So we're going to use the distance formula to find the length of line segment AB. Then we're going to use the distance formula to find the length of line segment BC. And then finally we'll use the distance formula to find the length of side AC. So sometimes drawing a sketch can help you to determine which sides you need to find the length of. And this is especially important when you have a quadrilateral, because it can get confusing. You might end up finding the length of a diagonal instead of the length of a side. Okay, so the distance between points A and B. So for this one, I'll call this x1, y1, and this x2, y2. So we want to do x2 minus x1, so 3 minus -3 squared plus 1 minus 4 squared. So we'll have 3 minus a -3. Again, subtracting a negative is the same as adding a positive, so 3 plus 3 is 6 squared. 1 minus 4 is -3 squared. Notice I'm keeping that -3 in parentheses because we have to square that. 6 squared is 36. -3 squared is +9. So we have AB is equal to the square root of 45. And we need to simplify that. So 45 factors into 9 times 5. 9's our perfect square, so square root of 9 gives us 3 square root of 5. Next, we need to find the length of line segment BC. So setting that up in the Pythagorean theorem will look like this. I'm going to do the square root of, and we want to do the change in the x values. So we'll take 3 minus 0, quantity squared, plus 1 minus a -2, quantity squared. So BC will be equal to the square root of 3 squared plus 3 squared, because the 1 minus a -2 turns into 1 plus 2, which is +3. So that's equal to the square root of 9 plus 9, which is the square root of 18. And of course that will simplify to the square root of 9 times 2, or 3 square root of 2. So let's label that side with 3 square root of 2. Okay, at this point we know for sure that the triangle is not equilateral, so we do need to find the length of the third side, line segment AC, to prove whether the triangle is isosceles or scalene. Okay, last time. Line segment AC, the length of it can be found by taking -3 minus 0, quantity squared, plus 4 minus -2, quantity squared. So AC will be equal to -3 squared plus 6 squared. And that comes from 4 minus a -2 turns into 4 plus 2. -3 squared is +9. 6 squared is 36. And this looks a little familiar because we saw it earlier. 36 plus 9 is 45. And that would simplify into 3 square root of 5, just like it did right up here. Okay. Using the distance formula allowed us to prove that two sides of this triangle are congruent. So therefore we can say for sure that the triangle is isosceles. Okay, the second major topic for our lesson today is midpoint. And it says find the midpoint between points A and B on the number line below. If you take a look, these are points are evenly spaced, and point B has a coordinate of 1. And notice that the distance from A to B is 4 units. You count over 1, 2, 3, 4. So the midpoint would be halfway, or at 2 units. So the midpoint of this number line is at -1, or the midpoint of line segment AB is at -1. Well, what we did, if you want to do it mathematically, you can take the coordinate for point A, which is -3, add it to the coordinate for point B, and then divide it by 2. -3 plus 1 is -2. Divided by 2, we get -1. Now, on the coordinate plane, we have not only x values, but we also have y values. So the midpoint formula is you take x1 plus x2 divided by 2. Then you take y1 plus y2 and divide it by 2. So the midpoint is the average of your 2 points. So the x-coordinate is the average of the x values. The y-coordinate of the midpoint is the average of the y values. So I'm finding the midpoint between each pair of points. We'll just take and add the x's. 6 plus negative 2 divided by 2. And negative 4 plus 8 divided by 2. 6 plus a negative 2 is 4. We still have to divide that by 2. Negative 4 plus 8 is 4 divided by 2. And our midpoint is at 2, 2. In our second example, number 8, finding the midpoint between these 2 points, we want negative 1 plus negative 2 divided by 2. Negative 5 plus 2 divided by 2. So negative 1 plus negative 2 is negative 3 over 2. Negative 5 plus 2 is negative 3 over 2. We'll just leave it like that. Now, it's not always the case that x and y are both the same. I just happen to make up 2 examples where this is what happened. Okay, in our last example, it says the point M, which is at 2, negative 3, is the midpoint of line segment AB. So here's line segment AB. We're not graphing it, just sketching it. And so we've got this point M, and M has coordinates 2, negative 3. It says if point A has the coordinates of negative 2, 3, we need to find the coordinates of point B, x, y. Okay, remember, the midpoint formula says that you take the x-coordinates of your endpoint, so negative 2 plus x, and you divide it by 2. You do the same with the y's, 3 plus y divided by 2. And this will give you the coordinates of your midpoint, which in this case are 2, negative 3. So it means that this right here would be equal to positive 2. So set those equal to each other. Negative 2 plus x over 2 equals 2. And this would be equal to the y-coordinate of the midpoint. 3 plus y over 2 equals negative 3. Okay, we can solve these equations by thinking of them as proportions. So put the 2 over 1 and then cross multiply. So 2 times 2 is 4, and that's equal to negative 2 plus x. Add your 2 to both sides, and we get x equals 6. So this means that the x-coordinate of point B has to be 6. Okay, solving for y, we'll do the same. Put negative 3 over 1 and cross multiply. We get negative 6, when we multiply here, equals 3 plus y. Therefore, y is equal to negative 9, because you have to subtract 3 from both sides. Now, you can check it. If you take negative 2 plus 6, you get 4 divided by 2, gives us 2 for the x-coordinate of the midpoint. And do the same thing with the y's. 3 plus negative 9 is negative 6, divided by 2 is negative 3. Now, there are some shortcuts to this, and I think you'll probably be able to devise your own method for finding the coordinates of the other endpoint. So make sure you check with your teacher to make sure that your method works in every case. All right, good luck on the homework.